So the very last thing to say about this is once we have the eigenvalues, once we know what the eigenvalues are supposed to be, in order to find the eigenvectors themselves, we just have to solve this equation, a minus lambda ix equals 0, by plugging in the lambda that we know into our matrix a minus lambda I, and then just augmenting it with the 0 vector, and then solving that in the usual way that we find the solutions of homogeneous equations. So just as one brief example, if I have this 3 by 3 matrix and I happen to know that -2 is an eigenvalue, now how would I have known that? I don't know. We would have had to probably solve a 3 by 3 determinant, which gives rise to a cubic characteristic equation, and cubic equations are notoriously much more challenging to solve than quadratic. But if we already know that -2 is an eigenvalue, then we just have to subtract -2 from the entries on my diagonal. If I subtract -2 from all the entries on my diagonal, then a minus -2 times I is going to give me a new matrix. Let's see, -1 minus -2, that's -1 plus 2, that's 1. So 1, 4, -2. And then -7 plus 2 is going to be -5, 9. And then 3, 0, 4 minus -2 is going to give me 6. And so, oops, I forgot a semicolon. That's that thing that keeps programmers up at night. So there is a minus -2 times I. And so then I would need to figure out how to solve this thing augmented with a 0 vector, right? Row reduce that thing augmented with a 0 vector. And so I'll put in my 0 vector here and then do the elementary row operations. And what you notice happens when I do this row reduction is that I get an RREF that has a row of all zeros. And that's not surprising, because if -2 really was an eigenvalue, that means that the determinant of a minus -2i needed to be 0. And so it needed to be a matrix that had a non-trivial kernel. And in order to have a non-trivial kernel, we have to have fewer than 3 pivots for this 3 by 3 matrix. And indeed, we have only 2. Right? And so then, if I were to finish solving this to find a basis for the eigenspace associated with the eigenvalue -2, I would just do the usual thing that we do to find a basis for the solution set of a homogeneous equation. I would just find my free parameter and solve for my bound parameters in terms of that free parameter.